We're looking at potential difference in a uniform electrical field, but the movement is slant. What does that mean? So this is a field and is an electrical field which is uniform. We have a charge which we move from point A to point B, and the displacement per se is slanted, making an angle of theta with the electrical field. Also, let theta be the angle between our electrical field and the displacement vector. Now, let's pick up a charge Q naught and let's move it. So the external field, the work done by it, will be equal to integration of all the work along the length A to B. You can find that by taking the dot product between the force, electrical force in this case, and the displacement vector. So when we open this up, we have this to be dr cos of theta. Because theta is important over here, I'm opening it up. What and all is constant? Well, theta is constant. What about the force? It too is constant because we have the electrical field to be uniform. And so the force will be constant. And so this turns out to be, oh my bad, need to take out the constant, minus of the force cos of theta and the integration from A to B, the length dr, we are integrating this. Now, the length dr, when you integrate from A to B, it will be equal to what? L. All the small chunks will add up to L. Agree? So this will be minus cos of theta into L. So we can take care of this negative with the help of cos theta. How? I'll give you guys a clue. This is linear pair, so this has to be 180 minus theta. Now think about it. Minus cos of theta is nothing but plus cos of 180 minus theta. Agree? Because of which we have this expression to be cos of 180 minus theta into L. Now, from this figure, remember this is 180 minus theta, right? We are looking at this particular angle. Can you help solve this expression? What is this expression equal to as per this diagram? The next clue would be something like this. I'm going to call this as point P and this length as D. Any idea? Yes. Cos 180 minus theta into L is D. Why is that though? Because, my bad. Because cos theta is adjacent by hypotenuse. As per that, so from triangle APB. So we are able to get this. So here D is distance of Q naught along the direction of distance. The Q naught has been displaced along the direction of has been displaced along the direction of the electrical field E. I guess it's as simple as that. Very simple thing. We have few constant things. We took it out. We integrated the length. And when we looked at the angle, it turns out to be that only the perpendicular distance matters. And that perpendicular, or in this case, sorry, parallel to what? Parallel to E. The perpendicular component, it's of no use. This entire expression, right, it's a work done by external force on Q naught. For a charge of 1 coulomb, we end up with finding the voltage, the potential difference divided by Q naught. So this entire expression will be E into D. As simple as that. Okay guys, you can pause and have a look.